received this new device. I haven't opened it yet. This is our official unboxing. I have no idea what this is. Still sealed up in its package. It came from Sequre, so it's going to be a tool of some type, I would think, because after all, this is the last device I received from them, was this Sequre cordless screwdriver and screwdriver bit set, same company. Let's see what we got this time. Looks like a soldering iron. This one's the MSS12 Intelligent Soldering Station. So let's take a look at what comes in the package. So we've got the iron itself. We've also got it's like a holder and a power supply, complete with power cable, and it operates on between 12 and 25 volts DC, so you need to use your own power supply to supply this. Uses one of these tips, these fancy tips with the built-in heater and the built-in temperature probe built in. This one's a T12-B2 tip, and it just fits in just like that. Now, if you think this tip type looks familiar, it is. I've already got a T12 from a different soldering iron that uses the same type of tip. This is a knife tip that I've got from another iron. Uses interchangeable tips. Tip just plugs in like that and tighten it in place. And then this will plug into the controller, which is going to have the temperature setting on it, and we just need to give it, as I say, 12 to 25 volts DC. So let me just power this up. I'll get my power supply going, and we'll test this one out and see how it performs. Now, the wattage of the iron itself is all totally dependent on the supply voltage. If we look at the instruction manual, if you feed it with 12 volts, you have a 16 watt heating element. If you feed it with 19 volts, you have 40 watts, and if you feed it with 24 volts, you have a 60 watt. And this is the times that it takes to heat up to operating temperature. I'm going to operate this with 24 volts. So let me get my power supply set up, and then we'll just we'll try it out here and see how it works. So we're looking at the polarity. The tip is negative and positive. So the side with the channel here is negative, and this is the positive side, and it is indicated here. So I've got my power supply set for 24 volts. We can power it up this way using the standard connector, and it will tell me that I'm feeding it with 24 volts. We also have the option of powering up with a PD power supply, like a USB-C. As long as you've got one that's rated as a PD 3.0, you can power it up with that. And this is one that I've got that actually was from another heating device. It comes with a silicon cord. If I plug that in, I can also power it up that way. So I can power it up either with my PD USB-C PD 3.0 power supply, or from an external source. I'm going to set the temperature. If I want to set the temperature to, say, first of all, let's set it to Fahrenheit. I like to work in Fahrenheit as opposed to Celsius for when I'm working with soldering irons. So the first thing you find when you plug it in is it's got a nice bright OLED screen which displays the temperature. And to get in and change the temperature settings, we just need to press the button, the switch lets you dial your temperature in, but to switch it on and off, you press the button. I'm going to switch it to Fahrenheit, so to do that I press and hold. Then I get into the secondary menu. I'm going to change the iron, and here's where we go, temperature compensation, so you can calibrate it. Buzzer, temperature unit Celsius, work temperature 300. Start heater is off, factory setting off, temperature shield on, temperature step 10. So I want to change this from Celsius, so I'm going to press and hold, and then change it to Fahrenheit, press and hold. Now I've changed it to Fahrenheit. See, now work temperature 572 degrees Fahrenheit. That's a little bit cold, I think. So let me just get into here and set that for my work temperature. Click. 700 degrees is typically where I solder at. So we just dial this up to 700 degrees. There we go. And other features: idle, sleep time, sleep temperature, so it'll cool down if you're not using it. It'll drop down to 392 degrees after 360 seconds. The OLED is to adjust the brightness. Voltage, low voltage, this is just to tell you you can set up for low voltage alert, etc. That would be good if you're running this from a battery, for example, which of course you could run this from a battery. Calibration is for calibrating the tip, and I'm not going to do that because it should already be pre-calibrated. About should just bring up the firmware version. And we're going to get out of that. We're back down to the normal main menu. So when you first to power it up, it's in stop mode, so there's no heat to the heating element. The heating element is cool. When I turn on, just press and it'll say work. And now here's how quick the iron heats up. This is running on 19.2 volts from a standard USB-C PD 3.0. So the iron is now up to work temperature. Actually overshot there, and now it'll come back down. And there it is. This one comes with a standard conical tip, which is actually my favorite type. I know some are going to say they prefer to use the knife tip. This one has its applications. It comes with a conical tip. That just my personal preference is a conical tip. That's what I learned to solder with and used throughout my career. Now what will happen is if this is not used, it should go to sleep. So let's just leave it sit and see how long it takes for this to go back to sleep. And you guys will be seeing me use this one a bit too, because it couldn't have come at a more perfect time. My old iron that I've been using for the last number of years, the cord has again broken. So every so often it loses connection with the thermocouple and it loses its temperature control. So I'm going to have to fix that again. So while I'm waiting to fix that, you'll see me using this new iron. And we'll run this one and put it through its paces and see how it performs. So this should, if the iron's not moved for a period of time, it should shut down and go into the standby mode. So we're just going to monitor it and see when it goes into standby and see what's required to get it back into work mode. Will it go back into work mode when I pick it up? There we go. It's now gone to sleep. Okay, so now the tip is cooling down. So what do I need to do? Do I need to push a button here, or when I pick up the iron, will it automatically switch over? Well, let's just pick up the iron. Will this moving the iron do anything? No, it doesn't. So once it's gone to sleep, it tells you it's gone to sleep. The iron will now cool down to its sleep temperature. Still going to keep the iron warm, but it's going to let it cool down. So at this point, it's probably not going to melt solder much. It's still hot enough to melt solder. It's still 470 degrees Fahrenheit. But it is cooling down. I can see that here if I'm melting solder. As the tip continues to cool. It's going to get down to its standby temperature, which I think was around 390 degrees So there it is. It's now at the standby temperature. Still hot enough to melt solder, but not really useful to do much work. To bring it up to operational temperature again, just press the button and that'll heat it up, and it climbs very quickly, as you can see. Now, having the iron cool down to its standby temperature is beneficial in two ways. One, having an iron at its full working temperature is going to shorten the life of the tip, and two, it's also going to create more of a fire hazard if that hot tip were to come into contact with something. So having the iron, after a period of disuse, automatically go to sleep and cool down to a temperature, not shut off completely, but cool down to the point where it's not going to be as hazardous as far as something that's touching against it, and it's also certainly going to extend the life of the tip, and getting it back to working temperature is just pushing the button. And if I tap the button, I can turn it right off completely. You see, now it says stop on the screen, so that's going to turn it off completely, and it'll cool right down. So it's got work and stop. When you turn it off, it'll shut right down, and if I melt my solder here, it'll cool right down. So now it's cooled down to the point where it doesn't melt solder anymore. I was just kind of sticking it in the blob of solder I had on the bench here from when I melted some before. But that's pretty much all I really need to show you on this. I'm going to put the link to this little soldering station in the description. It's kind of cool. I like the fact that I can just use my USB-C power supply. I don't have to set up a dedicated supply. It's going to provide more than enough heat. If you need that extra hot 60 watts, then yes, 24 volts into the connector on the back will do the job, or basically any 24 volt power supply. I figure let's take this little controller apart and just take a look at what it looks like, since it's got screws in it, and it's made out of metal, by the way. Feels like metal back anyway on it. I figure let's take this thing apart. Here's a look at the controller and the business end of the unit. It features an OLED screen. This is not an LCD. This is actually an organic light emitting diode, which are some of the more recent display technologies that emit light, so they don't require a backlight. And there it is there. You can see that little panel right there. If I plug this thing into power now without the, well, probably tell me if I plug it in without the iron, it'll probably give me a message. It says check, and it's going to beep. It says check tip, because the tip's not plugged in. But there's not a lot to it. We've got our tip plugs in here. These are going to be MOSFETs, I'm sure. These little ICs that look like ICs, but they're going to be the MOSFET controller to control the tip. And then you've just got your temperature measurement circuitry and the actual program, the controller, and some memory and the power input. This is software can be updated on this as well. So there's the flash memory right there on the side. That'll be the EEPROM. Buzzer, power connector. Construction wise, can't fault it. One last test for those of you wanting to see how quick it heats up at 24 volts. There you go. Very quick at heating from 24 volts. You want to see how much current it draws at 24 volts. 2.4 amps. And now it's getting up to temperature again, so the current drops. Anyway, that's a quick look. It's the model MSS12 by Sequre. Nice little soldering iron that I'm going to put into service here on my workbench. And I'll let you guys know on a long-term test how this one pans out. Thanks for watching. Link is in the description. Bye for now.